Okay, theoretical and experimental probability. Experimental probability is found using frequencies attained in an experiment or game. Theoretical probability is the expected probability of an event occurring. Okay, so theory is what should happen. So like if we roll a dice, the probability of a 2 on a die, on a number cube, would be 1 out of 6. So that's what the theoretical probability is. The experimental probability is what we actually get. So like right here, they actually did the experiment 100 times, and these are their results, the numbers showing. So they got 14 one time, 1 14 times, 2 13 times, 3 16 times, 4 19 times, okay, 5 21 times, and 6 17 times. So, for example, they said determine the experimental probability of rolling a 3, then compare it to the theoretical probability. So the experimental probability of rolling a 3 would be 16 out of your original 100, okay? So you could reduce that if you wanted. You could reduce that to 4/25, okay? But the experimental, that's the experimental probability. The theoretical probability, okay, is 1 out of 6, okay? So it's hard to compare those two because we have a fraction and then a fraction that doesn't have a common denominator. And then so it's hard to compare that. So if I take this to a percent, this would be 16%, and this would be 16.6%. So if we compare those two numbers, they're very close in what they turn out. So is the experimental probability of a 3 close to the theoretical probability? And yes, I would say yes, they are close. Okay, they're 0.6 off, which turned out pretty good. Okay, example 2, it says in a telephone poll, 225 people were asked for whom they plan to vote in the race for mayor. What is the experimental probability of Juarez getting a vote from a person selected at random? Okay, Juarez is 75. So 75 plan to vote for him out of 225. Okay, so 75 over 225 can reduce. It's divisible by 5, it's divisible by 25, but it's also divisible by 75, because 75 divided by 75 is 1, 225 divided by 75 is 3. So a third of the people were going to vote for Juarez. So that's the experimental probability right there, okay? Example 3 says 5,700 people vote in the election. How many can be expected to vote for Juarez? So here's my number. It's going to be a proportion here. Okay, we're talking about a third of the population voted. So 1 vote out of 3 people. Okay, so how many votes would he get out of 5,700 people? And if we cross multiply that, we can say 3x equals 5,700, and we divide both sides by 3, and you're going to get 1,900 people would be projected to vote for Juarez in that election. Okay, so that's a lot of times how they break down voting. Like if we took a poll of people voting here in Waco for the presidential election, you could push that off and say this many people voted in the national election. Would that be accurate? Probably not, but it's something that happens quite a bit. Okay, our last question on the examples, it says use the graph of a survey of 150 students, asked whether they prefer cats or dogs. Okay, this graph didn't get labeled, so I want you to go ahead and label that graph right here. Okay, cats and dogs. What is the experimental probability of a student preferring dogs? Well, they're at 132, so hey, there's dogs out of the total amount that they got, which would be 150. I need to simplify my experimental probability down, so I'm going to divide by 2 because I know that off the top of my head. So I got 66 over 75. Now, if you continue that, I can also divide it by 3, and I get 22 out of 25. So that would be the experimental probability of students preferring dogs. Suppose 100, B says, suppose 100 students were surveyed. How many students would be expected to prefer dogs? Well, if I take this simplified version of what we got, I can easily scale it up to 100. So if 22 out of 25 prefer dogs, then I can scale up to 100 and be times 4. So 88 out of 100 kids would prefer dogs. Okay, and the last question, C, says, suppose 300 students were surveyed. How many can be expected to prefer cats? Okay, well, cats is 18 out of 150. So we can do it that way. Okay, or we could say that, well, 88 out of 100 prefer dogs. So how many prefer cats? Well, it would be 12. So 12 out of 100. That gives us a little bit easier number to work with, but you need to make sure you understand where that 12 is coming from. Okay, so if that 12 is coming from there, you could still do it both ways. You could do 300 here, and this one actually scales up easily because it's times 2. Okay, so times 2 would give you 36, and I would have done it here times 3. So times 3 would be 36. So either way, 36 kids out of 300 prefer cats. Okay. Looking at the last page on the back side, it says determine the table shows the results of a fair number cube rolled 40 times. Remember, a fair number cube, in theory, every option 1 through 6, the theoretical probability would be 1/6. So determine the experimental probability of rolling a 4. Okay, so looking at 4, we got it 8 times out of my 40 times, which reduces to 1/5 because they're both divisible by 8, okay? And then determine the theoretical probability of rolling a 4. And I just kind of said that earlier. In theory, there's 6 options. 4 is one of your options, so your theoretical probability is 1/6. Determine the theoretical probability of rolling a 2. So I'm going to say still 6 options, and 2 is one of those options. Determine the experimental probability of not rolling a 6. So we want everything but a 6. So 1, 2, 3, 4, 5, and we're looking for experimental. So we're going to add these 5, 14, 15, 16, 24, 36. So 36 out of 40, which is, if you divide by 4, it's going to be 9/10. And then my last one, suppose the number cube was rolled 500 times. Based on the results, about how many times would it land on 5? Well, out of 40 times, it landed on 5 12 times. So out of 500, what would it get? Okay, so we're going to say 40 x 500 times 12. I'm going to do it this way because I like those zeros on the bottom. So I got 6,000. Divide by 40. So 600 divided by 4. I'll go in there one time. Drop down my 0. 4 going to 25 times. It's going to zero out, so we're going to put a 0 right there. So x is going to be 150. So 150 students, or 150, about 150 times it would land on 5. So that's the end of your 6-3 notes. Go back and look if you have any questions, or slow back and listen to it again if you need me to slow down, and check, make sure you got everything correct.